Good evening, and welcome. Get yourself comfortable, in whatever way feels easiest tonight. There is nothing you need to do, nowhere you need to go, and nothing you need to hold in your mind. Just allow my voice to be there in the background, soft and steady, as you drift gently towards sleep. Tonight, we'll take a calm wander through space, not in a rushed way, not in a way that asks you to imagine anything too vividly. Just quiet facts, simple, peaceful ideas, like a slow stream moving in the dark. When we look up at the night sky from Earth, we're looking into a kind of time machine. Light takes time to travel, so even the nearest stars, the bright, familiar points above us, are not seen as they are right now, in this exact moment. We see them as they were, some time ago, when that light first began its journey. It can be comforting to think of the sky that way, a gentle record of distance and patience, and time passing calmly. On a clear night, away from bright city lights, the sky can feel deeper. The darkness between the stars becomes part of the view. And you might notice that not all stars look the same. Some are slightly warmer in color, with a soft golden tint. Others look cooler, more pale, or faintly bluish. Those tiny differences can tell us something real. Color is linked to temperature, and temperature is linked to what a star is, and how it shines. From Earth, it's easy to think of space as a place full of objects. Stars, planets, moons, but most of space is empty. Not empty in a frightening way, just open, quiet, spacious. A place where, for long stretches, there is almost nothing at all. Even in areas that contain clouds of gas and dust, the material is often incredibly thin, far thinner than the air around you now. Space is not crowded. It's mostly stillness, with islands of light spread out across a very wide ocean of dark. Distance in space is so large that we use special units to talk about it. One of the gentlest ideas is the light year. A light year is not a measure of time. It's a measure of distance. The distance that light travels in 1 year. Light moves very fast, faster than anything else we know. And yet, the universe is so big that even light, moving at that incredible speed, still needs years, centuries, or far longer to cross it. Thinking about that can feel strangely soothing, not because it's complicated, but because it reminds you that your own small moment tonight is allowed to be simple. The universe is vast, and you can rest. The moon is the closest large object in space to us. It orbits Earth at an average distance of about 384,000 kilometers. That sounds like a lot, and it is. But in the scale of space, it's close enough that we've visited. Astronauts traveled there and left footprints, and those footprints can remain for a very long time, because there is no wind to erase them, no rain, no flowing water, just quiet dust, and long, steady darkness, and sunlight that moves slowly across the ground as the moon turns. When you see the moon, you're seeing sunlight reflected from its surface. The moon doesn't glow on its own. It simply catches the sun's light and sends a little of it back across space, to your eyes. Even that is a comforting image. Light travelling out, touching a distant surface, and returning gently to where you are. A calm loop of brightness. If you've ever noticed that the moon looks larger near the horizon, that's a trick of perception. Your brain compares the moon to nearby objects, trees, buildings, the shape of the land. High in the sky, it has nothing to compare to, so it seems smaller. The moon itself hasn't changed size. It's still the same quiet companion, moving through its orbit, night after night, month after month, a steady rhythm above us. Farther out than the moon, the planets are spread around the sun in a wide, flat arrangement, like a gentle disk. This is called the plane of the solar system. It exists because of how the solar system formed, from a rotating cloud of gas and dust long ago. As the cloud spun, it flattened, a calm, natural motion, shaping everything that came later. And in that flattened space, the planets continued to move, each one following its own path, held by gravity. Gravity is one of the quiet rules of the universe. It doesn't need noise or forceful pushing. It simply is. It draws things together, shapes orbits, gathers dust into worlds, and keeps moons circling planets with patient regularity. Here on Earth, gravity is the reason you feel held in your bed tonight. It's the reason the air stays close to the surface. And out in space, gravity is still at work, guiding the slow dance of stars and galaxies over unimaginably long times. The Sun is our nearest star, and it's already quite far away. Light from the Sun takes a little over 8 minutes to reach Earth, so when you feel sunlight on your skin, it began its journey 8 minutes earlier. That can make the Sun feel even calmer. A steady lamp, shining continuously, with warmth that arrives gently after its long, straight trip across space. Even though the Sun looks large in our sky, it's just one star among many. If you could travel far away from the solar system, the Sun would shrink into a single point of light. Not special looking, not marked, just one more star in the crowd. And that is not a sad thought. It can be peaceful, because it means our home is not isolated. It belongs to something wider, a larger neighborhood of stars, all shining in their own ways, across the dark. On some nights, you might see a faint milky band across the sky. It can look like a pale cloud, or a soft brushstroke, stretching overhead. That is the Milky Way. It's not a cloud in Earth's air. It's the combined light of countless distant stars, so many and so close together in that direction that your eyes blend them into a gentle glow. The Milky Way is our galaxy, and when you see it, you're looking along the plane of a great spiral of stars from within it. A galaxy is a vast collection of stars, gas, dust, and dark matter, all held together by gravity. The Milky Way contains hundreds of billions of stars. It's a number too large to picture in detail, so there is no need to try. You can simply let it be what it is, a quiet city of stars, spreading out in a wide spiral, with a soft, glowing center. And we are located far from that center, in one of the spiral arms, in a calmer suburb of the galaxy, you might say. A place with room to breathe. The center of the Milky Way is hidden from our eyes by clouds of dust. Dust in space is not like household dust. It's made of tiny grains, often carbon-rich or silicate-rich, drifting between the stars. That dust can block visible light, like a curtain. But with other kinds of telescopes, looking in infrared or radio wavelengths, we can sense what lies behind. Even then, we don't see the galaxy as a simple picture. We build understanding slowly, collecting signals, making maps, learning bit by bit over decades. It's the opposite of rushed. Space invites patience. If you've ever seen a photograph of the Milky Way taken from a very dark place, it can look impossibly bright. But our eyes are gentle and limited. In ordinary night conditions, we see only a faint glow. And that's perfectly enough. because the feeling of it is what matters. That calm awareness that you're under something enormous, and that it doesn't demand anything from you. It simply exists, quietly overhead. Our solar system is moving through the galaxy, not quickly in a way you would notice day to day, but steadily, all the time. The Sun, with all its planets, travels around the center of the Milky Way, completing one orbit roughly every 200 to 250 million years. That means the last time the Sun was in this same part of its galactic orbit, Earth was a very different place. Life was very different. And yet, the motion continues, smooth and unhurried, like a slow turning wheel. A long, calm cycle that doesn't care about busy schedules or restless thoughts. Even the stars you recognize in the night sky are moving. Constellations look fixed, like pictures drawn on the sky. But those stars are not connected to each other in space. They're at different distances, traveling in different directions. They only form patterns from our viewpoint, like shapes made by distant lights. Over thousands of years, those patterns shift, very slowly. So slowly that a human lifetime is barely a blink. The sky feels stable, because it is stable on the timescale of our lives. It's one of its quiet gifts. When you see a bright star, you might be looking at something much larger than the Sun, or much smaller. Some stars are giants, swollen and luminous. Some are dwarfs, compact and faint, but distance changes everything. A small star nearby can look brighter than a huge star far away. In the night sky, brightness is a mixture of size, temperature, and distance, and the mind can rest in that thought. Not everything that looks important is large. Not everything that looks small is insignificant. Sometimes it's simply closer or farther, and the universe keeps its own gentle balance. If you live in the northern hemisphere, one of the most familiar markers is the North Star, Polaris. It sits close to the direction of Earth's rotation axis. So, as Earth turns, most stars seem to circle around that point, while Polaris stays nearly in place. It's a calm anchor in the sky, not the brightest star, not the most dramatic, just steady and easy to find, if you know where to look. For centuries, people used it for navigation, trusting that quiet point of light. It's comforting to know that even in the wide dark, there are steady things. And as Earth turns tonight, the whole sky is turning with it. From your perspective, stars will rise and set slowly. The moon will move along its path. Everything continues, gently, without effort. You don't need to keep track of it. You can simply rest, here on the surface of a small planet, with air and warmth, as the universe carries on in the background, calm and indifferent in the most peaceful way. Out there, the Milky Way stretches across the dark, and here you're safe and allowed to sleep. Let that thought settle softly, like a blanket, and just keep listening, or don't, as your mind becomes quieter and the night goes on. As you lie here, breathing quietly, it can be soothing to remember that the Earth itself is moving, not in a way you can feel, but in a smooth, steady way, like a boat gliding across calm water. The planet turns once each day, bringing night to your side of the world, and carrying you gently through the dark. At the same time, Earth travels around the Sun, tracing a wide orbit that takes 1 year to complete. So even when you are completely still, you are also in motion, a kind of quiet traveling, happening without effort, while you rest. The orbit of Earth is not a perfect circle. It is slightly oval, only a little, and that small detail reminds you that nature often prefers gentle variations over perfect shapes. Even so, the path is stable. Gravity keeps it steady. And because of the tilt of Earth's axis, the amount of sunlight reaching different places changes through the year. That tilt is what gives us seasons, not the distance from the sun, but the angle of light, the length of days, the slow shift of where warmth falls. It's a patient design, and it repeats with calm reliability. You might imagine the solar system as a quiet arrangement of paths, planets in their lanes, each one circling the sun at its own pace. Mercury, the nearest planet to the sun, moves quickly, completing an orbit in only 88 Earth days. Farther out, Jupiter takes almost 12 Earth years to circle once, and Neptune, at the edge of the main planetary family, takes about 165 years. A year on Neptune is longer than a human lifetime. That thought can feel oddly gentle. Time is not one size. It stretches, and it changes, depending on where you are in the universe. The planets do not sit still in empty space. They are worlds, each with its own weather, chemistry, and history. But even without going into dramatic details, you can appreciate them as quiet shapes, moving through darkness. Some are rocky, like Earth and Mars. Some are giant spheres of gas, like Jupiter and Saturn. And some are ice giants, like Uranus and Neptune, made of different mixtures, with atmospheres and interiors unlike our own world. Each one is a different expression of what matter can do, when gravity gathers it together, and time is allowed to unfold. When we talk about planets and stars, we often imagine hard surfaces and bright lights. But a great deal of the universe is made of gas, hydrogen, helium, and other elements in smaller amounts. Gas can be invisible, and yet it can shape everything. It can drift into long, thin streams between galaxies. It can form clouds within galaxies. It can cool and gather, and eventually become the material for new stars. The universe has this quiet ability to recycle over very long times, without hurry. Even in our own solar system, there is leftover material from its early days. Small bodies, chunks of rock and ice, that never became planets. Some of them live in the asteroid belt between Mars and Jupiter. Others are farther out, in regions where icy objects orbit at great distances. They are like slow-moving reminders, keeping old pieces of the early solar system in cold storage. From time to time, one of these icy bodies travels inward. When it gets closer to the sun, sunlight warms its surface, and it begins to release gas and dust. That is how a comet develops its soft, glowing appearance, and its tail. The tail is not a sign of danger. It is simply sunlight and solar wind shaping a delicate cloud, streaming away gently. A quiet interaction between warmth and ice, written across the sky. The solar wind is another calm idea. The sun is always sending out a flow of particles, a thin, steady stream that travels through the solar system. We do not feel it on Earth because our planet has a magnetic field, a protective bubble that deflects many of those particles. That magnetic field is like an invisible shelter. It also helps create the aurora, the northern and southern lights, when particles interact with Earth's upper atmosphere. Even that is a kind of softness, a quiet glow, drifting and folding across the sky, like slow curtains of light. Magnetism exists on other worlds too. Some planets have strong magnetic fields. Some have weak ones. Some have almost none. Jupiter's magnetic field is powerful. It stretches far into space, forming a vast region around the planet. Saturn also has a strong magnetic field, and it interacts with the particles around it in gentle, complex ways. These invisible fields are part of the universe's hidden structure. You can't see them directly, but they shape paths and guide particles and create subtle patterns. It's comforting to know that not everything important is visible. Saturn's rings are one of the most peaceful sights in the solar system. They look like solid bands, but they are made of countless pieces of ice and rock, ranging from tiny grains to larger chunks. Each piece follows its own orbit. All of them together form the rings, like a soft, shimmering record of motion. The rings are thin compared to Saturn's size. If Saturn were the size of a room, the rings would be like a sheet of paper, delicate, flat, and wide. There is something soothing about that, a grand structure made of small, simple pieces, all moving in quiet coordination. Many planets have moons. Earth has one large moon. Mars has two small ones. Jupiter and Saturn have many. And some moons are as interesting as planets. They have their own landscapes, their own histories, their own subtle behaviors. But tonight, you don't need to hold too many names or details. You can simply take in the idea that moons are common. They are companions, circling their planets with steady patience, kept close by gravity. A gentle reminder that many worlds are not alone. The idea of an orbit is itself calming. An orbit is a balance between motion and gravity. If something moves forward fast enough and gravity pulls inward at the same time, it keeps falling around, rather than falling down. It's like a continuous, gentle curve, a path that repeats. Orbits can be nearly circular, or more stretched out. Some are tilted, some are aligned, but they all share that quiet balance. Forward motion, inward pull, steady repetition. It can feel like a peaceful rhythm, like breathing. You might also like the thought that the Earth is not traveling alone. The moon travels with us around the sun, and everything is moving together through the galaxy. A layered motion, rotation, orbit, drift. It is the kind of complexity that happens without effort. You do not need to manage it. You do not need to understand every piece. It continues whether you pay attention or not. That is one of the most restful truths of space. When astronomers study the universe, they do it by collecting light. Light comes in more forms than the kind our eyes can see. There is radio light, infrared light, visible light, ultraviolet, X-rays, and gamma rays. They are all part of the same family, different wavelengths of the same phenomenon. Some wavelengths pass easily through dust that blocks visible light. Others reveal heat, or energetic processes, or the movement of gas. By combining these views, we begin to understand objects that are far away. It is a slow craft, observing, measuring, comparing, building quiet knowledge over time, not with urgency, but with patience and care. When you see a photograph from a space telescope, you are often looking at colors that have been translated. Sometimes the colors match what your eyes would see. Sometimes they represent wavelengths outside human vision. The purpose is not to make it dramatic. It is to make patterns visible. Temperature, composition, structure. Even then, the result can look soft and painterly, like delicate clouds of light. And in a way, that is what many structures in space are. Clouds, spread across enormous distances, shaped slowly by gravity and radiation, and time. Between the stars, There is a thin mixture called the interstellar medium. It contains gas and dust. In some places, it is warmer. In others, colder. In some places, it is denser and begins to gather. When parts of it gather enough, gravity continues the work, pulling material inward, forming a denser core. Over time, that core can heat up, and eventually a new star can begin to shine. Starbirth is not a sudden event. It is a gradual settling, a long, quiet process, taking place in dark clouds, where light is dim and the universe is patient. These dark clouds are sometimes called nebulae. The word nebula simply means a cloud. Some nebulae are places where stars are forming. Some are shells of gas left behind by older stars, spreading out softly. Some are lit by nearby starlight, glowing gently in different colors depending on their chemistry and temperature. But even without focusing on endings or dramatic changes, you can let nebulae be what they appear to be in pictures. Great, calm drifts of light, like fog banks in deep space, stretching for many light years, slowly changing shape over thousands of years. A reminder that the universe is not rushed, and the stars themselves, those small points we see, are far more varied than they seem. Some are single, like the Sun. Many are in pairs, two stars orbiting each other. Some are in larger groups, moving together through the galaxy. Stars can also gather in clusters. Open clusters are loose collections of young stars. Globular clusters are dense, ancient gatherings, containing many stars packed into a relatively small region. From a distance, a globular cluster can look like a soft ball of light. Up close, it is a crowded city of stars, yet still calm, each star following its own quiet physics, each one shining in its own way. The Milky Way contains many such clusters. They orbit the galaxy like quiet companions. And beyond the Milky Way, there are other galaxies. Some are spirals like ours, with arms that curve outward. Some are elliptical, more like smooth, rounded swarms of stars. Some are irregular, shaped by interactions and gravitational pulls. Galaxies can be solitary, or they could be part of groups and clusters. Our Milky Way is part of a small family called the local group. And within that family, one of our nearest large neighbours is the Andromeda Galaxy. Its light takes around 2.5 million years to reach us. So, when you see a faint smudge of Andromeda in a dark sky, you're seeing ancient light travelling calmly across intergalactic space. Intergalactic space is even emptier than the space between stars. It is a wide, quiet gulf, but it is not perfectly empty. There are thin traces of gas. There are faint fields. There is dark matter, which we cannot see directly, but we infer from its gravitational effects. Dark matter is one of the universe's gentle mysteries. It does not shine. It does not block light. It simply seems to add extra gravity, helping to shape galaxies and clusters. It reminds us that the universe contains things we have not fully mapped, and that is all right. Not knowing everything can be restful. As you continue to settle into sleep, you can hold on to one simple idea. The night sky is not a ceiling. It is depth. It is distance. It is time. And yet, it is also familiar. The same stars, the same moon, the same slow turning of Earth, repeating quietly. Out there, galaxies drift and stars shine. Here, you breathe and rest on a small world with gentle gravity and a thin, protective sky. and everything continues, steadily, peacefully, as the night carries you onward. As you rest, it can be calming to think about starlight in a slightly different way. A star is not a flame. It isn't burning like wood or coal. A star shines because of fusion, a process where tiny particles join together, deep inside, under immense pressure. In the heart of a star, hydrogen atoms can combine to form helium. A small amount of mass is converted into energy, and that energy travels outward, layer by layer, until it finally leaves the surface as light and warmth. It happens continuously and steadily for a very long time. A star is like a quiet engine, powered by the simplest element in the universe, and governed by calm, reliable physics. The sun has been shining for about 4.5 billion years, and it has enough fuel to continue for billions more. There is no rush in a star's life. Even the changes that do happen slowly. For most of its existence, a star is in a stable phase, quietly balancing two forces. Gravity pulls inward, trying to compress it. Pressure from energy produced inside pushes outward. When these forces balance, the star remains steady. This balance is one of the most peaceful ideas in astronomy. A constant, gentle negotiation, held for eons, without thought, without strain. Stars come in different sizes. Some are smaller than the sun. Some are much larger. Size matters because it affects how fast a star uses its fuel. Smaller stars burn their fuel very slowly. They can shine for an extraordinarily long time, far longer than the sun. In fact, many of the smallest stars, called red dwarfs, may live for trillions of years. That is longer than the current age of the universe. It is an almost unimaginable patience, written into the fabric of small, steady stars. A red dwarf star is dimmer than the sun and cooler at the surface, giving it a reddish color. But it can be remarkably stable, a quiet, long-lasting presence. Larger stars, on the other hand, tend to use their fuel more quickly. They shine brighter and hotter, and their lives can be shorter. Even so, short in space can still mean millions of years. And the processes that shape these lives are not frantic. They are natural sequences, like seasons, unfolding at a scale far beyond human experience. You don't need to hold the whole story. You can simply let the idea settle that stars have lifetimes, and they pass through stages, slowly and predictably, guided by physics. Astronomers talk about a star's color and brightness to understand its nature. A hot star appears bluer. A cooler star appears redder. Brightness depends on size and temperature. From these clues, we can infer what kind of star we're looking at, and often its approximate age and future path. This is one of the gentle achievements of science. Without traveling to a star, without touching it, we can learn its character by reading its light. Light carries information, not only beauty, but detail, a kind of quiet message, crossing space to reach us. When light passes through gas, it can create patterns called spectra. Different elements absorb and emit light at specific wavelengths. So when we spread starlight into a rainbow of fine lines, we can see signatures of hydrogen, helium, sodium, calcium, and many others. This is how we know what stars are made of. It's reassuring, in a way, to learn that the same elements found on Earth also exist throughout the cosmos. The universe is consistent. The matter that makes up your world and your body is not foreign to space. It is part of the same broad, shared inventory of atoms. The heavier elements, like carbon, oxygen, and iron, were formed over long cosmic history. Early in the universe, most matter was hydrogen and helium. Over time, through generations of stars, heavier elements were created and spread. This is not a harsh thought. It is simply the universe's way of building complexity slowly. Atoms are patient. They combine, separate, and combine again over billions of years, shaped by gravity, heat, and time. And those atoms eventually become parts of planets, oceans, air, and living things. It's a quiet continuity, a long chain of calm transformations. In the night sky, some stars seem to twinkle more than others. Twinkling is not caused by the star itself. It's caused by Earth's atmosphere. As starlight passes through moving layers of air, the light bends slightly, and the star appears to shimmer. Planets usually twinkle less because they appear as tiny disks rather than single points. So even this small detail, this gentle flickering, is a reminder of where you are. You're beneath an atmosphere, a protective layer of gas, while the stars shine steadily beyond it. The twinkle is the soundless movement of air, written in light. The atmosphere also filters light from space. It blocks many harmful forms of radiation. It keeps Earth warm. It makes liquid water possible. It creates the sky's blue color during the day, and the soft reds and golds at sunrise and sunset. From space, Earth's atmosphere is thin, like a delicate skin around a sphere, and yet it shapes everything about our experience. It's another quiet shelter, holding you gently tonight. When you think about stars, it can be easy to imagine them as isolated points, but stars are often born in groups within large clouds of gas and dust. These clouds are cold and dark, and within them, denser regions form. As material gathers, it warms and compresses, and a young star begins to form. Around many young stars, disks of leftover material can appear. From these disks, planets can form over millions of years, as dust grains stick together, then build into larger clumps, and eventually into worlds. Planet formation is slow craftsmanship. It is gentle accumulation. The universe builds with time and repetition and quiet persistence. Our own solar system likely formed this way. Long ago, the sun was surrounded by a swirling disk. Within it, small grains collided and merged. Some became rocky planets close to the sun. Farther out, where it was colder, ice could survive, and giant planets could gather large amounts of gas. Everything you know as the solar system came from that disk, and from gravity's steady organizing hand. When you look up at the stars, you are looking at places where similar processes may have happened, and may still be happening, calmly and continuously. In recent decades, we have discovered many planets around other stars. These are called exoplanets. We usually cannot see them directly, because the star is so bright compared to the planet. Instead, we detect them through subtle effects. Sometimes a planet passes in front of its star from our viewpoint. The star's light dims very slightly, a tiny, regular dip. Sometimes a planet's gravity causes the star to wobble gently. These signals are small, but with careful measurement, they can be detected. And again, the method is patient. Observation over time, repeated patterns, quiet proof, built slowly. It is a soothing reminder that knowledge can be gathered calmly, without urgency. Some exoplanets are large and close to their stars. Some are small and rocky. Some orbit in days, some in years. There are planets unlike anything in our solar system. Worlds larger than Earth, but smaller than Neptune. Planets with thick atmospheres. Planets that may have oceans. It is a wide variety. and it suggests that the universe enjoys diversity, not randomness, but countless variations on simple physics and chemistry. A peaceful thought. A universe that can make many different kinds of worlds, without effort, simply by letting matter and gravity do what they do. Even so, the distances to these planets are immense. They are far beyond easy travel. They remain, for us, points of curiosity and quiet contemplation. And that's fine. There is no need to imagine rushing outward. You can simply enjoy the knowledge that the galaxy is full of stars, and that many of those stars have planets. A gentle abundance, a wide landscape of possibilities, existing quietly while you lie here, safe and still. The Milky Way itself is structured in layers. There is a thin disk where many stars live, including the Sun. There is a thicker disk with older stars, and there is a halo around the galaxy containing older stars and globular clusters. This halo is faint. It's like a soft envelope around the spiral. And through all of this, the galaxy rotates, slowly, taking hundreds of millions of years for one full turn. The motion is so slow, it feels almost like stillness. But it is constant, a calm rotation, carrying stars along like leaves drifting in a slow current. Between the stars, there are also regions lit by radiation from young, hot stars. These regions can glow because the gas is energized. Hydrogen, when energized in certain ways, can emit a deep reddish light. In long exposure photographs, these glowing areas can appear rich and colorful, but the reality is usually faint. The universe often glows softly, not brightly. Its light is spread across great distances. It is like a whisper rather than a shout, and that whisper has filled the galaxy for billions of years. You might also enjoy the idea that in space, sound does not travel the way it does on Earth. Sound needs a medium, like air, to carry vibrations. In the near vacuum between planets, there isn't enough matter for sound waves to move through in the same way. So space is not filled with noise. It is mostly silent. That silence is not empty in a lonely way. It is simply quiet, a vast hush. And inside that hush, light travels freely, carrying warmth, color, and information across the darkness. As you listen, you can let these ideas drift past without effort. Stars balancing gravity and pressure, light traveling for years, planets forming slowly from dust, galaxies turning like slow wheels. Nothing is urgent. Nothing is asking you to keep up. You are allowed to be small in the best possible way, resting on a steady planet, while the universe continues its gentle, silent motion around you. And if sleep comes, you can let it come naturally, as softly as starlight. If you imagine looking at the universe from very far away, you might expect it to be still. But almost everything in space is moving, not quickly most of the time, more like a slow drift, guided by gravity. Stars orbit within galaxies. Galaxies move within groups. Groups move within larger clusters. And in the background, the universe itself has been expanding for a very long time. Expansion doesn't mean everything is flying outward from a central point. It means that, on the largest scales, the space between distant galaxies increases with time, like a gentle stretching, happening everywhere at once. This expansion is one of the reasons distant galaxies often appear redder. As light travels across expanding space, its wavelength can stretch too. that stretched light shifts towards the red end of the spectrum. Astronomers call this redshift. It is a calm clue, a soft signal in light, telling us about motion and distance. The more distant a galaxy is, the more its light has been stretched during its journey. So even the color of faint light in the telescope can quietly reveal the shape of the universe's history. Thinking about deep time can feel surprisingly soothing. On Earth, time is often measured in days and weeks. In space, the natural units become much larger. Thousands of years, millions, billions. The Earth is about 4.5 billion years old. The Sun is of a similar age. The universe is older still, around 13 to 14 billion years. These numbers are vast, but you don't need to picture them. You can simply let them soften your sense of urgency. There has been plenty of time, and there will be plenty more time. The universe is not in a hurry. When we look far away, we look back in time. A galaxy 1 million light years away is seen as it was 1 million years ago. A galaxy 1 billion light years away is seen as it was 1 billion years ago. So the night sky is layered with history, different distances, different ages, all of it arriving together in the present moment as light. That means that, in a sense, the universe shows us its past all the time, not with drama, just with gentle honesty. The sky is a calm archive. One of the oldest kinds of light we can detect is called the cosmic microwave background. It is very faint. It comes from early in the universe's history, long before stars and galaxies formed. At that time, the universe was hotter and denser. As it expanded, it cooled. Eventually, light could travel freely for the first time. And that light has been traveling ever since. Over billions of years, it has stretched into microwave wavelengths, too faint for our eyes. But sensitive instruments can detect it. It is like a quiet afterglow, filling all of space from every direction. A soft reminder that the universe has a long memory. This background glow is remarkably smooth, almost the same temperature everywhere. But it has tiny variations, gentle ripples in brightness. Those small variations are important because they reflect the early structure that later grew into galaxies and clusters. Even the largest structures begin as tiny differences. A slight unevenness, a small, calm ripple, expanded over time into the vast patterns we see today. It's a comforting thought. Big things can grow from small beginnings without force, simply through time and patience. Galaxies themselves can come in many shapes. Spiral galaxies have arms that curve outward, like slow pinwheels. Elliptical galaxies are smoother, more rounded, and often filled with older stars. Irregular galaxies have less symmetry, sometimes because they've been shaped by interactions with neighbors. These shapes are not random. They are the results of gravity, of rotation, of collisions and mergers over billions of years. Even when galaxies interact, the spaces between stars are so vast that stars rarely collide directly. Instead, the galaxies pass through each other like ghostly swarms, their gravity reshaping the overall structure, stirring gas, triggering new star formation. It is motion and change, yes, but on such slow, immense scales that it feels like a calm shifting of clouds. The Milky Way has neighbors. The large Magellanic Cloud and the small Magellanic Cloud are smaller galaxies nearby. They are visible from the southern hemisphere as faint, cloudy patches. They orbit the Milky Way, drawn in by gravity, and our larger neighbor, Andromeda, is also part of our local family. Andromeda and the Milky Way are moving towards each other very gradually. Over billions of years, their paths will bring them closer. This is not something to worry about. It is so far in the future that it is more like a gentle fact about the universe's slow dance. A reminder that even galaxies have long-term relationships, moving quietly through time. Closer to home, you might find it soothing to think about the planets again, but this time as worlds with their own rhythms. Mars has seasons, like Earth, because it also has an axial tilt. Its year is longer than ours, about 687 Earth days. Jupiter has a day that is surprisingly short. It rotates in around 10 hours, making it slightly squashed at the poles. Saturn's atmosphere has long-lived patterns, including a famous hexagonal shape near its north pole, a kind of persistent wave pattern in the clouds. These are not alarming details. They are simply the natural outcomes of rotation, fluid motion, and time. The universe forms patterns and then keeps them going, quietly, like a slow tide. Venus rotates very slowly and in the opposite direction to most planets. So, if you could stand above Venus and watch, its day would feel very long. Uranus is tipped on its side, so its seasons are unusual, with long periods of sunlight and darkness at its poles as it travels around the Sun. These differences show that there is no single way for a planet to be. Each one is a variation, a different outcome of the same basic ingredients: gravity, motion, matter, and once formed, they continue, turning and orbiting, with calm regularity. Moons, too, have their own gentle behaviors. Many are tidally locked, like our moon. That means they rotate once in the same time it takes to orbit their planet. So they always show the same face to the world they orbit. It's a quiet kind of synchrony, a steady companionship. Tidal forces also create slow stretching and squeezing, which can warm the interiors of some moons over time. Even warmth can come from gentle, repeated motion, not from fire or violence, but from steady flexing over long periods. Space often works that way. Small forces, acting patiently, creating lasting effects. The rings around some planets are another example of order within motion. Not only Saturn, but also Jupiter, Uranus, and Neptune have rings. Though Saturn's are the most visible. These rings are made of countless particles, each one following an orbit set by gravity. Some rings are shaped and maintained by small moons, called shepherd moons, that travel near the ring edges. Their gravity nudges ring particles gently, keeping the rings sharp. It's a lovely idea that small moons can guide a much larger structure just by being present, just by moving steadily alongside. When you look at the starry sky, it's easy to forget that the Earth's surface is a moving platform. The horizon feels fixed, the ground feels still, but the planet rotates and carries you with it. The rotation is smooth. At the equator, the surface moves at over 1,000 miles per hour, yet you feel nothing because everything around you is moving together. Motion can be quiet when it is shared. That is another restful thought. You are traveling through space right now, but gently and safely, held by gravity, wrapped in air. And while the Earth travels, it is also part of a larger system. The Sun and its planets orbit the center of the Milky Way. The Milky Way moves within the local group. The local group moves towards a region of higher mass, drawn by gravity across immense distances. These are layered motions, nested inside one another, like a set of slow, turning gears, each one moving at its own pace, all of them part of a larger flow. It's a reminder that your own small worries do not need to be carried tonight. The universe is already carrying so much, quietly, without strain. There is also a calm beauty in the fact that space is full of cycles, day and night, months, seasons, orbits, the rise and set of constellations across the year, the slow precession of Earth's axis over thousands of years, shifting the position of the North Star over long ages. Even on Earth, the sky changes in slow cycles. Ancient people watched these patterns and learned to measure time, not with clocks at first, but with stars. That is a deeply peaceful link between the human mind and the universe. We looked up, we noticed quiet repetition, and we found order. As you rest, you don't need to measure anything. You don't need to keep track. You can simply let the sense of slow cosmic movement soothe you. The Earth turning beneath you, the moon orbiting, the planets circling the sun drifting through the galaxy itself, rotating and traveling through space, everything continuing in gentle motion while you remain still and safe and warm. And if your thoughts begin to fade, that is perfectly fine. The universe will keep moving calmly as you fall asleep. If you'd like a quieter image to hold in your mind, you can picture the space between stars, not as a harsh emptiness, but as a wide, calm distance, a place where light travels without resistance, a place where tiny grains of dust drift for ages, barely touched, barely disturbed. In those long stretches, nothing needs to happen quickly. Everything has time. The dust in space is very small, often smaller than the width of a human hair by many orders of magnitude. But even tiny grains can have an effect. They can scatter and absorb light. They can help cool clouds of gas by providing surfaces where molecules can form. Over time, dust can gather into thicker lanes, especially in spiral galaxies, where it traces the structure of the arms. When we look at images of galaxies, those dark lanes are not gaps. They are clouds, quietly present, shaping what we see. Darkness in space is sometimes simply dust, and sometimes simply distance. It can be comforting to remember that darkness often has an explanation, and a softness to it. In the Milky Way, dust gathers along the plane of the galaxy. This is why the Milky Way band looks brighter in some places and dimmer in others. We are looking through a disk filled with stars, but also filled with clouds. Some starlight reaches us directly, some is filtered, some is blocked. The result is a sky that feels textured, like a gentle fabric, not perfectly even, but subtly varied. The universe rarely gives perfectly uniform scenes. It offers calm complexity instead. Among the gas between stars, there are also molecules. Simple ones, like hydrogen molecules, and more complex ones too. In the coldest, densest clouds, chemistry can continue for a long time. Atoms and molecules meet on dust grains, stick, react, and sometimes form larger structures. This does not mean life is forming everywhere. It simply means that the building blocks of chemistry are widespread. The universe is not chemically barren. It is full of gentle reactions, happening slowly in the dark. That idea can feel peaceful, a quiet kind of creativity, taking place far away, without noise. Some regions of space glow because nearby stars illuminate them. If the gas is thin and spread out, the glow can be faint. But over huge distances, even a faint glow adds up to something visible. Nebulae can appear like soft veils, or curved wisps, or slow arcs. Their shapes are sculpted by light, by winds from stars, and by gravity. They are not frozen, they change, but on timescales that make them seem almost still. A nebula is like weather, slowed down by millions of years. In star-forming regions, gravity gathers material into clumps. As those clumps grow denser, they begin to collapse inward. In the center, a protostar forms. At first, it is not yet a full star. It is warm and bright from the heat of contraction. Over time, as the core becomes hot and dense enough, fusion can begin, and the star joins the long, steady phase of shining. Star formation is not a single moment. It is a gradual becoming, a slow settling into balance. It's a lovely thought for a sleepy mind. Things can take their time to become what they will be. Around young stars, disks of dust and gas can remain for a while. Within these disks, tiny particles collide. At first, they may stick because of electrostatic forces, like dust clinging together. As they grow, gravity begins to help. Small clumps become larger clumps. Larger clumps can become planetesimals, the early building blocks of planets. All of it is quiet. No hammering, no sudden construction, just gentle collisions, countless times, over long ages. A planet is the result of patience. Even after planets form, smaller debris remains. Some becomes moons, some remains as rings, some stays as smaller bodies, asteroids and comets, quietly orbiting. In a way, a solar system keeps its history around it. It doesn't tidy everything away completely. It leaves traces and leftovers, moving along in calm paths. This is true in our own solar system, and likely true in many others. It's a comforting kind of imperfection, a reminder that not everything needs to be finished or polished. You can also think about how space looks in different kinds of light. In visible light, we see stars and glowing clouds. In infrared, we can see heat and objects hidden by dust. In radio waves, we can map cold gas and subtle emissions across galaxies. In X-rays, we can detect very energetic regions. Astronomy is like listening to a quiet orchestra, with different instruments playing beyond our ordinary hearing. Each wavelength adds another gentle layer of understanding, and none of it needs to feel intense. It is simply the universe speaking in many voices, most of them soft, most of them distant. The space between galaxies contains thin gas too. Over huge scales, there are filaments, long, faint strands, where matter is slightly denser. And between these filaments are voids, regions with fewer galaxies. When astronomers map the distribution of galaxies, it can resemble a delicate web, not a rigid structure, more like a lacework. This large-scale pattern is sometimes called the cosmic web. It is one of the calmest images of the universe, vast, slow, and lightly connected, as if gravity has gently drawn matter into threads over billions of years. Galaxies gather in groups. Groups gather into clusters. A cluster can contain hundreds or thousands of galaxies, bound together by gravity. Within clusters, galaxies move slowly, orbiting the shared center of mass. There is hot gas between the galaxies too, so hot that it shines in X-rays. But again, you don't need to imagine heat as something harsh. It is simply energy in motion, spread thinly across an enormous volume. Even hot gas in space can be incredibly sparse, just a few particles per cubic centimeter. Space teaches you that words like hot and cold, dense and thin, mean different things across different scales. The idea of scale is one of the most soothing lessons in astronomy. On Earth, a few kilometers can feel far. In space, The distance to the nearest star beyond the Sun is more than 4 light-years. That nearest star system is called Alpha Centauri. It is actually a small group of stars, and it includes Proxima Centauri, the nearest of them to us. Even so, it is so far away that with today's technology, reaching it would take a very long time. So, we don't think of space as a place we need to conquer or rush through. We think of it as a place we can observe patiently from home, and that is enough. It can be restful to know you don't have to go anywhere to be connected to the cosmos. You can simply look, or listen, or wonder quietly. Telescopes are, in a sense, calm machines. They do not reach out to touch distant objects. They simply collect light. They gather photons that have been traveling for years, or centuries, or millions of years, and they guide those photons into sensors, or into eyes, so that we can see. When you look through a telescope, you are receiving light that has crossed space. It is like receiving a message sent long ago, a slow postcard, arriving late, but still beautiful. Sometimes, astronomy relies on long exposures. A camera is left open to gather light over minutes or hours. This allows faint details to build up. A soft glow becomes visible. A dim nebula gains shape. A distant galaxy emerges from darkness. There is a gentle metaphor there. If you give something time, more appears. If you slow down, subtleties come into view. You don't have to chase them. You simply allow them to accumulate quietly. The human eye, too, changes in darkness. When you spend time in low light, your eyes adapt. They become more sensitive. You begin to see fainter stars. This is why stargazers often avoid bright lights. It's not for mystery. It's simply because the body needs time to adjust. The night rewards patience, and that is a calm idea to carry into sleep. Your mind also adapts when you let it. If you stop feeding it bright, sharp thoughts, it becomes more sensitive to quiet. It begins to soften. It begins to drift. Out there, beyond the atmosphere, the stars do not twinkle. Twinkling is caused by air. In space, starlight is steady. If you could sit somewhere far from Earth, without an atmosphere, the sky would be different. The sun would be a bright, crisp disk. The stars would be sharp points, and the darkness would be deep and clean. Not frightening, just pure, a very quiet canvas. Here, on Earth, the sky has its own softness. The atmosphere scatters light, giving the night a gentle glow in many places. Even far from cities, there is natural air glow, faint light produced by chemical reactions high in the atmosphere. It's subtle, but real, so even the night has its own gentle brightness. You are wrapped in a thin, living layer of air, always doing small things, always moving, always protecting. And above that layer, the universe opens out, calm and wide. You can rest in the thought that you are held between two quiet vastnesses. The ground below, steady and dark. The sky above, deep and full of distant light. And in the middle, you, breathing softly, letting sleep come whenever it wishes. Somewhere in the distance, beyond the reach of ordinary sight, there are worlds that never see a sunrise quite like ours. A planet's day depends on how fast it turns. Its year depends on how wide its orbit is. Its seasons depend on its tilt, and its sky depends on what kind of star it belongs to, and what kind of air, if any, surrounds it. Here on Earth, we're used to a soft blue sky in daylight. That blue comes from sunlight scattering through our atmosphere. Shorter wavelengths scatter more easily, so blue spreads across the sky. At sunset, the light passes through more air, and the blue scatters away, leaving warmer colours. It's a gentle daily lesson in physics, happening without effort, over and over. A quiet reminder that light and air are always interacting. If Earth had no atmosphere, the sky would look darker, even in daytime. The sun would still be bright, but the space around it would remain black. That's what astronauts see in space, not because space is harsh, but because there is no air to scatter light. Darkness in that context is simply clarity. Nothing is wrong. It is just the natural view when air is not there to soften it. Atmospheres can be thick or thin. Some are mostly nitrogen and oxygen, like ours. Some are rich in carbon dioxide. Some contain hydrogen and helium. Some are hazy, with clouds of different materials. An atmosphere can act like a blanket, holding warmth. It can also shape weather, winds, and patterns that repeat. Even the word weather can be comforting, because it suggests rhythm, a kind of restless calm, moving, shifting, settling, and moving again. Our own solar system has a variety of atmospheres. Mars has a thin one, mostly carbon dioxide. Because it's thin, heat doesn't stay near the surface as easily, and temperatures can swing widely between day and night. Venus has a much thicker atmosphere, also rich in carbon dioxide, with clouds high above. Jupiter and Saturn have deep atmospheres, blending gradually into their interiors, with no hard surface you could stand on. They are worlds of layers, pressure increasing slowly as you go down. Like a deep ocean of gas, you can let these differences pass through your mind like drifting clouds. No need to picture them sharply, just a sense of variety and quiet complexity. Even rocky planets can have very different landscapes. Some are covered in craters, preserving ancient impacts because they have little erosion. Some have plains shaped by flows long ago. Some have tall mountains. Some have wide basins. Here on Earth, wind and water constantly reshape the surface. On other worlds, the shaping can be slower or nearly absent. So, the surface becomes a kind of record, a preserved memory. It's a gentle thought. Some places keep their stories for a very long time. The moon is one of those places. Its surface shows marks from impacts that happened long ago. With no thick atmosphere, no rain, and no running water, changes happen slowly. Over time, tiny impacts and sunlight can alter the fine dust, but the basic shapes remain. The moon's grey plains, called Maria, were formed by ancient lava flows that filled large basins. They look smooth from a distance. Up close, they are textured with small craters and dust. A quiet landscape, resting in stillness. You might also like the thought that the moon's phases are not changes in the moon itself, but changes in how much of its sunlit side we see. The moon is always half lit by the sun. As it orbits Earth, our view changes. Sometimes we see a thin crescent, sometimes a half, sometimes a full disk. It's a slow, comforting cycle, taking about a month, a repeating pattern you can glance at without thinking, and feel time passing gently. The moon also influences the tides on Earth. Gravity pulls more strongly on the side of Earth closer to the moon, and less strongly on the far side. This creates gentle bulges in the oceans. As Earth rotates, coastlines move through these bulges, creating tides. It isn't a perfect, simple system, because coastlines and ocean depths matter too. But the underlying idea is calm, a distant companion, tugging softly at the seas, a quiet connection across space, felt as a slow rise and fall along the shore. Other planets have tides too, and some moons experience tides so strongly that they are gently warmed inside. This warmth can keep internal layers softer, and sometimes encourages subtle activity over long times. Again, it's not about drama, it's about persistence. A steady flexing, a slow kneading, producing warmth little by little. It's one more example of how the universe can create effects without loud events, just repeated motion and time. When you look up at the planets in the night sky, they appear as bright points, like stars. But they don't make their own light. They reflect sunlight. That's why they follow the path of the zodiac, close to the plane of the solar system. Their steady movement among the stars was one of the earliest clues that they were different. Ancient sky watchers noticed that most stars held their positions relative to each other, while a few wanderers drifted slowly. The word planet comes from an old term meaning wanderer, a gentle name for a gentle motion. Sometimes, if you look carefully, you might notice that planets shine with a steadier light than stars. Stars twinkle because of our atmosphere. Planets, appearing as tiny disks rather than points, twinkle less. It's a small detail, and a calming one. Even the way something looks can hint at its nature. The sky gives quiet clues if you watch slowly. The sun itself, though it seems constant, has subtle rhythms. On its surface, there are regions of magnetic activity that can create sunspots. Sunspots look darker because they are cooler than the surrounding surface. They can come and go, changing over days and weeks. There is also a longer cycle, lasting about 11 years, in which the number of sunspots rises and falls. This doesn't mean the sun becomes unreliable. It remains steady for life on Earth. It simply has patterns within its steadiness, like gentle variations in a long, calm song. The sun's light is not only visible light. It includes infrared warmth, ultraviolet, and more. Our atmosphere filters much of the ultraviolet. Our magnetic field helps guide charged particles around us. Together, these create a safe environment at the surface. It can feel reassuring to know that Earth has multiple layers of protection, quietly doing their work. You are held by gravity, wrapped in air, sheltered by magnetism, while the sun shines from far away. When we talk about stars beyond the sun, it can be helpful to remember that they are not all like our star. Some are smaller and cooler, some are larger and hotter, but nearly all stars spend most of their lives in that balanced phase, quietly converting fuel into light. For a long time, a star is simply a steady lantern in the dark. And because the universe is so old, it contains stars at many different ages. Young stars, surrounded by leftover material. Middle-aged stars, stable and calm. Older stars, changing slowly as their fuel changes. It's like a forest with trees at different stages, all growing at their own pace. When a star eventually begins to run low on hydrogen in its center, it changes gradually. The core can contract, heating up. Outer layers may expand. The star can become larger and cooler at the surface, taking on a redder hue. This is one of the ways stars change with age. It is not sudden. It is not violent. It is simply a slow shift in balance. A different arrangement of pressure and gravity. A new steady state for a time. For stars like the sun, this long story ends quietly. After many stages, the star may shed its outer layers gently into space. Those layers can form a glowing shell of gas, lit by the remaining hot core. From far away, these shells can look like delicate bubbles or rings. They are called planetary nebulae, though they have nothing to do with planets. They are simply the softly released atmosphere of an aging star, drifting outward, thinning as it expands. In time, that gas becomes part of the interstellar medium again, recycled material, ready to join future clouds, and perhaps future stars. The star's core remains as a white dwarf, small and very dense, glowing with leftover heat. Over an immense time, it cools slowly, a quiet ember, fading gently. For larger stars, the ending is different, but you don't need to hold the details tonight. The main comfort is this: the universe recycles. Stars do not vanish without leaving gifts. They return material to space in one way or another, and over long ages, that material mixes into clouds. Gravity gathers clouds. New stars form. New planets may form. The universe is a slow turning wheel of transformation, never rushed, never wasteful. Even endings become beginnings, quietly. This recycling is one of the reasons we find heavier elements in planets and people. Carbon in your body, oxygen in your breath, iron in your blood, calcium in your bones. These atoms were formed long ago in the history of the cosmos. They traveled through space in thin gas and dust. They became part of new clouds. They gathered into new systems. And eventually, they became part of Earth. It's not something you need to feel emotional about. It can simply be restful, a sense that you belong to the same universe you're thinking about, not separate from it, made of it. When you're lying quietly, it's easy to feel that your life is small and contained. But you can hold a softer truth. You are part of a planet, part of a solar system, part of a galaxy, and all of it is part of the wider universe. This doesn't make you responsible for it. It simply places you gently within it. A small, warm point of awareness, resting inside a much larger, calm structure. Even the notion of direction in space is gentler than it seems. Up and down are local ideas, defined by gravity. In space, there is no universal up. There is simply position and motion. Things drift, orbit, and rotate. If you could float far from planets and stars, you might not feel any pull at all. You'd be in a kind of quiet weightlessness. Not falling, not rising, just suspended. A peaceful thought, even if you never experience it. A reminder that the universe allows different ways of being held and different kinds of stillness. So as you breathe, slowly, you can let your mind drift among these gentle facts. Reflected sunlight making planets shine, atmospheres shaping skies, moons pulling tides, stars balancing gravity and pressure, old stars releasing their material softly back into space, everything moving, and yet everything calm. And here, on Earth, you can rest. Your bed is steady, your room is quiet. Outside, the planet turns. Above, the sky holds its distant lights, and nothing requires your attention. Only sleep, arriving when it's ready, as softly as the night.